Hello guys, welcome sa subject natin for today, MKAB401 Review Mechanics. And for today, we will be discussing the dynamics part of mechanics. We'll focus for this session, for this lesson, yung kinematic side natin. Okay? So, learning outcome natin for this session are as follows: to state and illustrate yung formulas natin in kinematics and to solve problems involving theory of kinematics. Okay? So, topics to cover. So, for this session, we will just cover the first part or first type of kinematics, which is yung translation, then focusing more on rectilinear translation tsaka yung tinatawag nating motion curves. Okay? So as a review, we have here a definition of dynamics. So ano daw ba yung mga iba't ibang branches ng dynamics as mentioned earlier? So we have first yung definition ng dynamics. So define siya as a branch of mechanics that deals with bodies and motion. So the difference with this one is meron na tayong movement na nangyayari doon sa system natin. Unlike doon sa statics natin, we are considering bodies at rest. So for this particular part of the subject or the lesson, ngayon, in motion na yung body natin o yung particle natin. And then we divide dynamics into two branches, which are kinematics, natawag, and kinetics. So for your semifinals, the one included will be kinematics and your finals will be kinetics. So for today, we will be discussing kinematics and will focus only dun sa translational part niya. Okay? So pag sinabi kinematics, the geometry of motion is uh, yung concern natin. And this term is used to define the motion of a particle of a body without considering yung forces causing the motion itself, no? So kapag kino-consider na natin yung mga force acting on the body, dun papasok si kinetics. Pero for today's lesson, it will be about kinematics lang. Okay? And kinematics as defined is focused more on motion. Pag sinabi natin motion, meron tayong change in position ng body. So from halimbawa point A to point B, we have change in position. Okay? So, and then it is further divided into three classifications. So as I've said earlier, this session will be focused on translation part only. Okay? So, meron tayong translation, rotation, and plane motion. So, for today, translation yung focus natin. And translation is defined as the motion of a rigid body or a body in which a straight line passing through any 2 points of its particle always remain to be parallel to its initial position. So pag sinabing translation, yung movement natin from one point to another point is defined along the initial position or naka-straight line lang siya. Specifically, rectilinear translation yung tawag natin sa kanya kasi nga it's moving on a straight line. Meron naman tayong tatawag na curvilinear translation. So yung path ng movement ng body natin is on a curve. So ano ba yung mga example nito? Yung mga projectile motion natin that are example of rectilinear translation. Curvilinear translation. But for today, rectilinear translation mainly for straight line. So yung example natin dito is ito nga meron tayong a car moving on a straight road, no, on a highway. So sabihin natin nag-start siya at this point and mag-end siya dito at this point. So kung ano yung mga pwedeng property na makuha natin sa kanya, yung velocity niya, yung distance na travel niya, yung time it take to travel from point A to point B. So yun yung mga concern natin. So ang isang example pa ng rectilinear translation are falling bodies natin, yung mga free fall. Like for example, this one, meron tayong ball na dinrap natin at certain height. No? So let's say, nasa taas tayo ng roof ng bahay natin. Then we try to uh, hindi throw it, try to free fall ng ball. So it will start from rest, kaya yung velocity niya is 0. And then after some time, it will develop a velocity dahil sa dahil sa pagkuha o dahil sa present ng gravity natin kasi pinupull ng gravity ng earth yung object natin na mapalapit siya dun sa ground natin, kaya nagkakameron siya ng increasing velocity. Once we go lower nung height natin kapag free fall siya. Okay? So we will deal with examples for this one later so that we can visualize how can we solve such problems. Okay? So in dealing with rectilinear translation, here are some of the formulas being used or some types ng tinatawag natin, kinaklasify natin siya. First one is yung uniform motion natin. So uniform motion meaning constant ang velocity natin. When the velocity is constant, meaning hindi siya nag-change from one point to another. So kung halimbawa nag-start siya at 20 meter per second, hanggang matapos yung problem, 20 meter per second lang siya. And kapag hindi tayo nagkameron ng change in velocity, ibig sabihin wala din tayong acceleration. Kasi si acceleration is defined as the change in velocity, no? So kapag wala tayong change in velocity, hindi tayo nag-increase ng velocity and hindi tayo nag-decrease ng velocity, meaning yung acceleration natin is zero. So hindi siya nag-accelerate or nag-decelerate at a certain distance. Okay? Then next is we have yung variable acceleration. Variable acceleration because we are depending it with the change in time, no? So ito yung mga relationship natin na si acceleration daw is related with velocity kapag kinuha natin yung kanyang first derivative, no, ng velocity. So ibig sabihin a change in velocity with respect to time is equals to the acceleration. So as to sa velocity naman natin, related naman daw siya sa distance s natin by getting the change in distance divided by the change in time. Okay? So, yung pwede natin makuha ang relationship sa kanya is given as follow. Taking yung value ng dt for each formula, then substituting and then cross-multiplying, we will have this particular relationship of the velocity, then change in velocity is equals to area times change in distance. Okay? Where A may either be a function of v, t, or s, or nv may be either a function of t or s. Okay? And we have the third one wherein yung constant naman yung acceleration natin. So meaning, hindi nag-change yung acceleration natin from a certain point. No? Sinasabi naman sa problem yun. And then, ibig sabihin, kung meron tayong acceleration, we have a change in velocity. Kaya meron tayong tatlong formula na kailangang i-consider. So basically, ito yung kailangan memorize talaga natin. Itong tatlong formulas na to. Okay? So yung first formula natin is getting the final velocity. No? Then second formula natin is getting the distance. And then third formula natin is getting the final velocity using both initial velocity values and the acceleration and the distance we are considering. Okay, so some textbook explain how to calculate this one or how to get this equation, pero galing din yan dito sa relationship natin sa variable acceleration, no? So when we try to integrate itong given function natin and when we select a particular limit, no? Halimbawa, from rest, then from a particular period, maglalabas din tayo sa formula na to. Okay? So, for convenience, for easy reference, I already projected na lang yung formula for you to use in the future problems. Okay? Then when dealing with free falling body, ito yung sinasabi ko kanina na straight path din yung kinoconsider natin. Always na ang initial velocity natin kapag free falling siya, ang initial velocity natin is equals to 0. Ang kaibahan niya kapag halimbawa nagto-throw upward naman tayo, so same lang din naman, 'di ba? Straight din yung path niya. So halimbawa ito free fall, so from a certain height mababa siya, no? Free fall ang tawag diyan. And when we try to bawa from the ground, tapos tinrow upward natin, so throwing upward ng mismong ball natin, anong kaibahan niya? So dito, yung initial velocity natin is equals to 0. Okay? Kasi free fall nga siya. So ibig sabihin, from rest, binitawan natin through the presence of gravity. Kasi gravity, ah ihilahin niya, no? Dahil may mass yan, ihilahin niya yung mismong ball natin, pababa. So, kaya nagkakameron ng change in velocity. So, pagdating natin sa point na to, meron siyang final velocity. No? Kaibahan naman sa pag-throw ng ball, meron tayong initial, no? Kasi kailangan natin ng pwersa. Okay? Ibig sabihin, kailangan natin ng pwersa para siya umakyat, no? So, kailangan ng initial velocity sa kanya. Tapos ngayon, yung final velocity niya o yung para ma-reach niya yung pinakamataas niyang pwedeng ma-reach, yung magiging velocity niya doon at that point will be zero. So kapag naging zero na siya, yung pagbalik niya from the highest peak ng kanyang location, through si gravity na din yung hihila sa kanya pababa. Okay? So basically, pag ganito mga problem na natuturo tayo, ang hinahanap naman natin is yung distance o yung extent kung saan naging uh, yung pinakamataas na na-reach nung binato natin pataas na bola. Okay? And this formula is also taken from this formula. Okay? So, pakita ko lang yung una, no? So, yung PF is equals to VI plus AT, no? Since ang initial velocity natin kapag free falling body, again, is 0. So, VF natin will be equals to 0 plus, and then acceleration present natin is yung gravity natin, no? So, magiging GT. Kaya meron tayong formula dyan na V is equals to GT na ito yan, no? Taken yan dun sa first formula natin for constant acceleration. Okay? And later, i-ano natin yung signage ng ating gravity. Depende sa motion natin. Okay? So, let's apply na yung napag-aralan nating formulas sa example, no? So, let's have the first example. So, ang condition, we have two cars, A and B, have the same velocity of 25 meters per second in the same direction. Ang condition is, the car A is 73.5 meters behind B when car B applied brakes, causing the car to decelerate at a constant rate of 3 meters per second squared. Okay? So, questions are, what time will A overtake B? Next, how far will car A travel? And C, how far will car B travel? Okay? So, drawing muna natin yung scenario. So, we have two cars. So, sabihin natin ito si car A and si car B. So, paano ko nalamang ganyan yung condition? Kasi sabi, A is 73.5 behind B. Okay? So, ibig sabihin yung distansya nito is 73.5 meters. Okay? And then nakalagay, they have a velocity of 25 meters per second. Okay? So, yung velocity na yan, same sa direction ng motion natin, no? So, meron tayong 25 meters per second to the right. Okay? When the brakes are applied to B. So, nag-brake si B, anong mangyayari sa kanya pag nagbe-brake ang car? Eventually, upon some time, mag-stop siya, ibig sabihin, no? So, pwedeng dito sa portion na to, i-assume natin na si B is nag-stop na. Okay? So, kung mag-stop siya, anong velocity natin doon? Ang velocity natin pag nag-stop ang movement natin will be 0 na to. Okay? And yung change in velocity na yan, nag-cause yan ng deceleration. Okay? Na against dun sa dun sa motion natin, no? Na ang value daw is 3 meters per second squared. So negative 3 meters per second squared. Okay? So tanong ngayon, in what time will A overtake B? So dito sa position ni B, what time makakalampas si A? So sabihin nyo, travel nga, anong oras siya makakalampas dito sa kung saan tumigil si B, nung tumigil na siya. Okay? So dito, pwede natin lagay dito na ito yung distansyang tinravel ni B. And then itong from position ni A hanggang dito sa position ni B, ito yung ita-travel niya. So, distance A. Okay? So, yan. So, yan yung figure natin, working figure natin. So, to calculate, kailangan magkameron tayo ng relationship. And then from that figure, we can arrive with anong relationship? Relationship nung distance A and distance B, no? We can say na si distance A is equals to distance ni B plus yung distance ni A kay B na 73.5 meters sa start of the problem, no? So, yan yung pwedeng relationship natin. So, para makuha si SA, kailangan natin si SB. And si SB, kailangan natin i-calculate. Paano natin makakalculate si SB, no? So, si SB, pwede siya makalculate dito sa condition natin kay B. Since meron na tayo dito ng change in velocity, so meron tayong constant acceleration. So, ibig sabihin, pwede natin gamitin yung constant acceleration formula. Okay? So, and ito yun, no? Constant acceleration formulas. And kailangan natin si SB. So, kung si SB, alin bang may S? Itong second and third formula natin. No? Pero analyze natin. Meron tayong VI, no? So, meron tayong 25 na initial. Meron tayong acceleration na given, pero wala tayong time. So, hindi natin pwede makalculate directly si SB. Tingnan natin yung first formula. Meron ba tayong final velocity? Yes, kasi stop at rest na yung carbon natin. So, zero na si VF. Then si VI, meron tayo. Acceleration, meron tayo. So, makaka-calculate natin yung time it take for B to stop, no? Para tumigil si B ng pagtakbo. Okay? So, let's use that info. Okay, so, ito kay B, no? Lagay ko lang dito. Kay B. So, from ito, VBF o yung final velocity ni B equals to VIF plus ATB. Okay? So, yan yung first formula natin. So, substitute natin. This will be 0 into 25 no? Meters per second. Plus, acceleration natin is negative 3 meter per second squared. Again, deceleration tayo kaya negative siya. Or opposing tayo ng action natin, ng movement natin, kaya naging negative siya, no? So, kung to the right yung assumption natin ng movement ng car natin, si deceleration or si acceleration is opposing that direction, kaya negative siya. Okay? Then we have there TB. Then transposing that, we will have TB is equals to 25 over 3 seconds. Okay? So, ito yung value ng TB natin, yung time B natin. Okay? Once na meron tayong time B, anong pwede natin gamitin? So, pwede natin gamitin sa second formula, no? Or si third formula. Maalin na sa dalawa. To identify yung value ni S, no? Pero ito, since direct na yung formula niya, we can use it already, no? Meron na tayong VIT, meron na tayo niyan lahat. So, we can use that. So, pwede natin ma-identify si SB ngayon, no? Equals to VBI TB plus 1/2 ATB squared. Okay, substituting the values, we have 25, then 25 over 3 plus 1/2, then negative 3, then 25 over 3 squared. Calculating sa calcu. So, you have to manual input it, no? 25 times 25 over 3 plus 1/2 times negative 3 times 25 over 3 squared. That will be equals to 104.17 meters, no? So, ito daw yung distance ni B, yung tinravel ni B before stopping. Okay? So, makukuha natin si SA ngayon, no? 104.17 meters plus 73.5 meters, we will have a value of SA or yung distance na tinravel ni A to overtake si B as 177.67 meters. So, ito yung kailangan total na ita-travel niya para ma-overtake niya. Pero yung first question natin, in what time will A overtake B? What time? So, Since si A, hindi naman sinabing mag-stop siya or meron siyang increase in velocity, nag-change siya ng velocity, pwede natin i-assume si A na constant velocity siya. And yung formula natin for constant velocity is to S is equals to VT, no? So, balikan natin dito. So, consideration naman natin is si A, no? Yan, si A. So, SA is equals to VA TA. Okay? So, anong meron tayong values diyan? Ang wala tayo ay si TA. Si SA na-calculate na natin just a while ago. And si VA is given sa problem natin as 25 meter per second. So, si TA natin can be calculated as SA over VA. So, TA is equals to 177.67 meters all over velocity of 25 meters per second. So, upon calculating 177.6 divided by 25, we will have how much? A value of 7.107 seconds. Okay? So, this will be the time it takes for A to overtake B. So, this is our answer for letter A. Okay? Letter B, how far will car A travel? Fortunately, nasolve na din natin. So, this will be our answer. No? Ito yung kailangan niyang i-travel para malampasan niya si B. And then, gaano kalayo daw yung na-travel ni B? So, ito po yung na-travel ni B. Okay? So, coincidentally, habang sinasolve natin yung letter A, nasolve na natin yung required for B and C. And ganito usually yung problem sa mechanics, no? Lagi siyang related with each other. Okay? Next. Okay, yan. So, we try now to analyze yung condition natin kapag throwing naman tayo, free fall tayo, no? So, yan. So, a stone is thrown vertically upward and returns to Earth in 10 seconds. What was its initial velocity? How high did it go? And what time did it travel until it reaches the highest point? Okay? So, when we throw a rock vertically upward, no? So, ganyan yung magiging itsura niya. And then, at some point, titigil yan. And then, yan, bababa siya ulit. Okay? So, assuming same location yan, no? Pinakita ko lang ganyan para mas ma-visualize natin. Okay? So, assume natin na ito is si point A, point B, then point C. So, si point and point C, same location siya, no? Si point B is yung highest point before going down ulit nung object natin na tinapon natin. Ang sabi sa kanya, pag throw upward ng stone, nag-return siya sa Earth in 10 seconds. So, ibig sabihin, yung time to travel from A to B, no? Tapos pupunta sa B to C, 10 seconds daw yung kanyang tinravel. So, ibig sabihin, yung T, time to reach A, B, plus time to reach B and C, equals daw yan sa 10 seconds, no? First question, what was its initial velocity? So again, para mag-throw tayo ng isang object or stone, kailangan natin ng puwersa, no? Pero hindi natin concern yung value ng force na i-apply natin. Ang concern natin is yung travel ng stone. Kasi nga, kinematics pa lang tayo ngayon. So, ano yung magiging velocity ngayon at A? No? Yun yung first question. And then, pagdating din sa B, sabi ko nga, pag na-reach na yung highest point natin, no? Ano nangyayari? Yung velocity natin is nagiging equal to 0 na siya. Bakit? Dahil habang nagta-travel siya pataas, no? Meron tayong gravity na nagpo-pull downward dun sa ating object, no? So, hinihila siya pababa. Kaya eventually magze-zero yung velocity natin at point B hanggang bumaba na siya. Okay? And then tanong, at what time did it travel until it reaches the highest point? So, lagay din natin dito na yung ano yung distance nito, no? Na tinatawag nating h, small letter h, is yung distance na travel from point AC hanggang B. Okay? So, ayan. So, masasolve natin to by using itong relationship natin nakuha do sa first part natin. Okay? So, kailangan consider natin each direction, no? So, pwedeng upward muna from A to B and then tsaka tayo mag-focus sa B to C. Okay? So, unahin natin si A to B na scenario. Okay? So, kay A to B na scenario, velocity natin is upward, no? And then, kamaya tayo ng change in velocity. So, ibig sabihin, pwede natin gamitin yung constant acceleration formula. So, VF is equals to VI plus AT. Ang VF natin dito is VB. VB, which is will be 0 then eventually. Then yung A natin is yung gravity and then T. Okay? T, tawagin kong AB. Okay? So velocity natin will be 0. This will be yung unknown natin. Then anong value ni gravity? Since downward sa gravity, so kinuha natin as positive si velocity na upward. So downward si velocity gravity. So gawin natin negative. Lagay natin 9.81, no? Kasi nakalagay ba? Hindi talaga nakalagay, no, kung English or metric yung ano natin. So lagay natin represent as G na lang muna natin, no? For the time being. Negative G TAB. Bakit? Kasi si G is may dalawang value, no? Sa SI 9.81 meter per second squared. Sa English siya po ay 32.2 feet per second squared, no? Kaya mahalaga na alam natin yung values niya. Kaya hindi mo natin siya na-represent. So pwede natin gawin para makuha si VA, transpose natin yung second term. This will be GTAB, no? So we have our first equation. Okay? Next. Ano bang pwede natin gamitin formula? So kailangan natin mahanap si H, no, yung distance, no? And we can use the second formula. Okay? So H, so si S dun sa formula natin ng constant acceleration, no? Pwede natin gamitin si H na dito, no? H na yung gagamitin natin. Okay? Okay, malilito, no? So si H yung gagamitin natin. So this will be S. Dito ko ituloy sa ano, no? This will be S is equals to VIT plus 1/2 AT squared. So applying dito sa AB natin. So this will be H is equals to VA TAB plus 1/2 negative G TAB squared. Okay, so we will have H is equals to VA TAB minus 0.5 G TAB squared. Okay, and then anong pwede natin substitute? Si VA natin, nilagay natin as ito yung value niya, GTAB, di ba? So pwede natin H is equals to GTAB times TAB minus 0.5 G TAB squared. Okay? Pag simplify natin, this will be 0.5 G TAB squared. Okay? So we have our equation number 2. Okay? So yan yung value ng H natin in terms ng TAB. Okay? So kung wala na tayong magamit sa segment AB, ngayon is segment, ano naman tayo? Segment BC. Okay? So segment BC. So same lang din yung gawin natin, no? Pero kay segment BC, free fall na siya, no? So yung BF is equals to VI plus 80 natin. So yung VI natin dito will be, ito ay magiging VC Okay? So, kahit hindi na pala ito. Kahit diretso tayo dun sa S. No? So, S is equals S. Si SBC equals yan kay SAB. No? Or equals din sa H. So, sabihin, H is equals to BIT plus 1 half AT squared. So, this will be H is equals to VBT plus 0.5. And then, ano mangyayari dun sa sign natin? So, yung sign natin, yung velocity natin, yung direction natin is pababa, and then si G natin is same direction. So, nagiging positive na dito si G. No? Okay? T B C squared. Okay? Then, when we simplify, we will have formula na H is equals to VBT. So, ang VB natin is, again, this will be 0. So, ito, wala na to. H is equals to 0.5 GTBC squared. Okay? Equation 3 natin, pero pwede natin i-relate si equation 2 and equation 3. No? Since para silang H, so sabihin, H is equals to H, so 0.5 GTAB squared is equals to 0.5 GTBC squared. So, ibig sabihin, from this relationship, magka-cancel out yung G, yung 0.5, then yung square root natin, magka-cancel out din yung squared. So, ibig sabihin, TAB daw is equals to TBC. So, from our formula na TAB plus TBC is equals to 10 seconds, this will be 2AB, 2TAB, okay, sorry, is equals to 10 seconds, or TAB is equals to 5 seconds. Okay? So, ito yung nakuha nating time for TAB. 5 seconds siya. So, para makuha si initial velocity, balikan lang natin sa equation 1. So, VA is equals to GTAB. So, wala tayong value for G. So, depende kung ano yung nasa choices, no? So, let's try na metric yung system natin. So, ang G natin is 9.81 meter per second squared times yung 5 seconds natin. Ang initial velocity natin is equals to 4. So 9.81 times 5, that is 49.05 meter per second. So this will be our answer for letter A. Okay, letter B, how high it will go. So how high? So ang consider natin is equation 2 kasi height yung pinag-uusapan natin, no? So substitute lang natin. So equation 2. So H is equals to 0.5, 9.81 tapos 5 squared. So H natin is equals to 0.5, 9.81 times 5 squared. That will be 122.625 meters. Okay, so this is our distance or how high natin tinapon yung stone. Okay, and then last is at what time natin ma-achieve yun. So already na-answer natin yung pinakhuli, which is yung TAB natin. Okay, so this will be our answer for this problem. Okay, next. Okay, a ball is dropped from the top of a tower 80 feet high at the same instant that a second ball is thrown upward from the ground with an initial velocity of 40 feet per second. Okay, when do they pass each other and where do they pass each other and with what relative velocity they will pass? Okay, so condition natin, meron tayong building. Ito yung ground natin. No? Yan daw yung tower. Sabihin natin tower na yan. No? Ayan si ball. No? Ito is, distance natin is 80 feet. Okay? Na-drop natin si ball. And then same instant, meron si ball na magtuthrow ng ball dito. Okay? So, yung direction ni ball 1, no, is going dito. Direction ni ball 2 is pataas. Okay? Same instance siya. Tanong, when do they pass each other? So, a certain point, magmi-meet sila, no? Sabihin natin dito sa point na to. Yan sila nag-meet. Okay? So, mula dito sa initial position niya, papunta dito, tawagin natin X, no? And then, kaya 80, gawin natin ang X natin ay ito. Yung initial position nitong tinapon natin pataas. And then ito will be 80 minus X, no? Neglecting yung height ng ball, no? I-assume natin na mismo doon sa top ng tower siya nilatlag. Okay? So at this point, dito sila magpa-pass through. So ibig sabihin, dito, yung imaginary ball natin, tsaka itong ball natin pangalawa, magiging magkatapat sila. So at what instance sila mangyayari? Okay, yun yung pinapahanap sa atin. So ibig sabihin, anong pinaka-condition natin? Yung time, tawagin natin si A to, si B. Yung time ni A, dapat ay equals ni B. Okay? So yan yung condition natin. So kailangan maghanap tayo ng formula kung paano natin maka-calculate yan. Okay? So kailangan maximize natin yung given. Yung given natin is meron tayong distance, no? Ano pa? Yung itong tinapon pababa, ang initial velocity niya, syempre, since free fall tayo, 0 yan. Itong nasa baba, tinapon siya, may initial velocity din yan. Which is sinabi naman. No? Yung initial velocity nito is 40 feet per second. 40 feet per second. Okay. So, kunin natin yung each condition. So, doon tayo sa A, no? Doon sa ball A. Yung inam natin pababa. Okay? Yung pababa. So, yung gagamitin natin yung sa distance. So, SA is equals to initial velocity times time plus 1/2 ATA squared. Okay? So, yung A natin dito is, syempre, yung ating gravity, no? Which is lagi siyang papunta sa Earth. Downward lagi sa gravity. Okay? So, SA natin dito will be 80 minus X is equals to, ito will be 0 na kasi ano nga siya, no? Free fall siya. So, 1/2 ng G. So, G natin, since ito ay English, 32.2 feet per second tayo. Okay? So, negative 32.2 feet per second. Times yung acceleration natin, ay yung time natin na unknown din. Okay? So, pwede natin gawin, simplify natin, 80 minus X is equals to, times natin to, this will be negative. So, dapat pala, since yung motion natin is pababa, and yung gravity natin is pababa, so same motion siya, so dapat positive na lang to. Itong gravity natin, no? Dapat hindi siya negative. Okay? So, this will be 16.1 PA squared. Pwede natin X is equals to 80 minus 16.1 PA squared. This will be our first equation, no? Considering yung ball A natin. Okay? Next, yung sa B natin, so A, so sa B, yung sa B natin is thrown upward, so SB is equals to VIT plus 1/2 ATB squared. So this will be, yung SB natin is X, then initial velocity natin is 40, then TAB natin, TB natin, di natin alam yung time, plus 0.5, yung acceleration natin, since yung motion natin is upward and then yung gravity natin is opposing that motion, dapat negative to. Okay? And then TB squared. Simplify lang natin. X is equals to 40 TB minus 16.1 TB squared. Okay? Since meron tayong dalawang value ng X, so equation 1 and equation 2, no? So X is equals to X. So 80 minus 16.1 TA squared is equals to 40 TB minus 16.1 TB squared. Okay? Mapapansin natin, inassume natin kanina na equal yung TA and TB. So ito kahit TA squared siya and TB squared siya, since pares siyang negative, pag tinranspose natin yung isang term and then change natin yung isang variable, yung TA gagawin natin TB, magka-cancel out lang siya, no? Ibig sabihin nito, cancel out na to. Then we were left with 80 is equals to 40 TB. So TB natin will be equals to 2 seconds. Okay? So yung tanong, when do we pass is after 2 seconds. Okay? Next. Question is where, no? Where will they pass, no? So tricky, no? Check natin parehas kasi dalawang location. Pwedeng from top of the tower or from the ground, no? So kung from the top of the tower, so substitute lang natin sa x. Okay? Yung x natin is equals to 80 minus 16.1 2 squared, no? Maka-calculate natin value is 80 minus 16.1 times 2 squared, that will be 15.6. So 15.6 feet, ito ay from the ground. Okay? Or, no? Yung 80 minus x natin, which is 80 minus 15.6, this will be 64.4 feet from the top of the tower. Okay? So, dapat check natin yung given, yung choices, no? Kung alin sa choices yung nakalagay. Okay? Then last, with what relative velocity they will pass. So, relative velocity, so kunin nyo lang yung final velocity ng each condition natin, no? So, yung yung relative natin, no? I-ano nyo lang yung yung final velocity ng A minus yung final velocity ni B, no? So, I will let you try this one. So, dapat yung answer nyo is 40 feet per second. Okay? So, kunin nyo lang mula do sa formula ng constant acceleration, yung value ng BAF and ni BBF. And pag minusin nyo, so dapat ito yung makuha nating value. Okay? So that's for number 3. Next is number 4. So yung given natin dito is distance na naka-function yung term niya. Okay? So variable acceleration yung gagamitin natin formulas dito. Okay? So let's read the problem. A car is traveling at the speed of V naught on a straight level road. After the brakes are applied at t is equals to 0, the motion can be approximated by the function of distance as x is equals to t cubed over 100 minus t squared plus 17t, where x is the distance traveled in meters and t is the time in seconds. Questions are, which of the following gives the value of V naught? Then next is, what is the distance required for the car to stop? And then what is the maximum acceleration during braking? Okay? So one thing na kailangan natin itandaan na to get yung velocity, pwede natin siya makuha by differentiating yung value ng distance natin with respect to time. And then to get yung acceleration natin, we can derive yung value ng velocity natin with respect to time, or we can double derivative, no, yung ating distance with respect to time. Okay? So may given naman tayong time na distance na ito yung function niya. So i-apply natin ngayon. Okay? So yung first question, ang sabi sa kanya, which of the following gives value of V naught, no? So ano yung magiging value ni V naught if yung time natin is equals to 0 kasi initial nga siya. Okay? So kailangan kunin muna natin yung value ni V. So yung S natin is in terms ni X, no? Which is given as T cube over 100 minus T squared plus 17T. So all we need to do is to get yung kanyang derivative with respect to time para makuha yung velocity equation natin. So that will be 3T squared over 100 minus 2T plus 17. So yan agad yung equation natin. And then we just need to substitute yung value na 0, no? Para do sa time. So yung first and second term natin will be disregarded. So ang V naught natin will be equals to 17 meter per second. So yun po agad yung answer sa number 1 natin. Okay? Next, number 2. So sa number 2 natin, pinapahanap is which of the following gives the distance required for the car to stop. Okay? So yung anong distance, no, para mag-stop yung car. Okay? So given yung x equals to t cube over 100 minus t squared plus 7t. Okay? Okay. So kung mag-stop yung car, ano mangyayari? Yung velocity natin doon will be equals to 0 kasi hindi na siya moving, no? So gamit yung formula natin for the velocity, 3t squared over 100 minus 2t plus 17. Okay? So yung na-derive natin yun dito, ha? Ito yun. Okay. So velocity is 0. So 0 is equals to 3t squared over 100 minus 2t plus 17. So nagigitong 0 is equals to 3t squared minus 200t plus 1,700. And then using yung ating quadratic equation, we will have a value of t1 is equals to 10 seconds and t2 is equals to 56.67 seconds. So dalawa yung value ng t natin. So hindi pa natin alam kung alin dyan yung gagamitin natin. Okay? Pero check natin, pinapanap is yung distance. So substitute natin sa value ng x, no? Value ng x natin is again t cube over 100 minus t squared plus 17t. And then once we substitute yung value ni 10 seconds sa formula ng x, makukuha tayo ng 80 meters dito. And then yung x2 natin is equals to negative 428 something. No? 428 meters. So kung i-assess nyo kung alin yung mas i-accept natin, so the distance will never be negative. No? So therefore, yung answer natin should be yung positive 1. So see, 80 meters tayo. Okay? So, sabihin, yan yung required natin. Okay? And for number 3, which of the following gives the maximum acceleration during brake? Okay? During brake. So, ibig kunin lang natin yung derivative ng velocity natin. Okay? So, that will be 3 times 2, t over 100 minus 2. Okay? Then this will be a is equals to 60 over 100 minus 2. Since ang time natin, nung nag-break tayo ay 0, so a natin will be equals to negative 2 meter per second squared. So ibig sabihin may deceleration tayo. Yung maximum deceleration natin for the problem will be equals to negative 2 meter per second squared. So ito yung sagot natin for number 3. Okay? So, ibig sabihin hindi laging by formula ng constant acceleration gagamitin natin sa problem. Depende sa given. So, there are cases that function yung binibigay sa atin. So, we need to know how to calculate also problems involving this kind of questions. Okay? And then another type na ginagamit in application kapag rectilinear translation is yung tatawag nating motion curves, no? So yung motion curves, minsan ang given is yung itsura ng curve as time distance, no? Or velocity distance or acceleration distance na axis. So paano natin siya i-calculate? So luckily for us, para lang siya yung shear and moment diagram natin sa structural theory, no? Kaya madali siyang maintindihan. So the motion of an object can be represented by motion graphs. So common motion graph includes ito nga, displacement time graph, velocity time graph, and acceleration time graph. May iba pang kind ng time graph. Actually, may 5 sila, no? Merong displacement velocity graph, merong displacement acceleration, and then merong velocity acceleration graph. Okay? Pero ito yung mas common sa kanya, no? Kaya ito yung tuturo ko. So basically, ganun din siya. Kung makikita nyo dito, from the acceleration, no? Makikita nyo, para ma-plot nyo yung velocity, kukunin nyo yung area niya, no? And kapag kinukuha natin yung area nung current curve natin, nag-increase tayo ng degree ng curve, no? So from constant or linear na 0, punta tayo sa from linear na 1 yung degree, punta tayo sa second degree, no? Which is ito. From constant na 0, linear, and then meron tayong quadratic yung kasunod, no? Para quadratic is parabolic na siya. And then meron tayong third degree curve. Okay? So, ito yung ilan sa mga formulang ginagamit natin. So, kailangan mo yung area and centroid kapag halimbawa gusto mong i-check, no? Kung tama yung na-produce mong curve para dun sa, halimbawa from acceleration, check mo kung ano yung distance na mako-compute mo. Okay? So, by using area moment, check mo yung value niya with the answer. So, later meron tayong example for that. Okay? So, I think mas maganda i-apply natin sa example to, no? Para mas ma-appreciate natin. Okay? So, a car starts from rest and reaches a speed of 48 meters per second in 15 seconds. The acceleration increases from 0 uniformly with time for the first 6 seconds, after which it remains constant. Which of the following gives the constant acceleration, velocity after 6 seconds, and distance traveled in 15 seconds? So, basta alam mo lang yung pagkakasunod-sunod nung tatlo, no? Pwedeng gawa ka ng graph. Gawin mo na agad for 3 graphs na agad, no? So, ito yung una. This is for acceleration. Okay. Yung kasunod, this is for velocity. Then yung last is for the distance, no? So, kailangan, ganito yung form niya. AVS or SVA. Dapat yung pagkakasunod niya parang di ka malito. Okay? So, balikan natin yung given. The car starts from rest and reaches a speed of 48 meters per second in 15 seconds. The acceleration increases from 0. Okay? So, from 0 yung acceleration natin. Okay? And then, uniformly with time for the first 6 seconds. Okay? So, lagyan natin ng additional. Yan. So, ito yung 6 seconds na mark, no? Uniformly increasing from 0 papunta daw sa a certain. Yan. Okay, so yung acceleration natin at 6 seconds. And then, after which it remains constant. So, constant na siya pagkatapos dito. So, yan. So, yan yung ibig sabihin niya. Okay? So, si acceleration, si velocity, paano si velocity? Si velocity is nakadepend siya dun sa itsura nung acceleration natin. So, starts from rest din siya, and then nag-reach siya ng 48 meter per second nung 15 seconds na. So, ito si 15 seconds, no? So, ma-reach natin si 48 meter per second. Pero hindi natin alam yung itsura ng graph niya. Okay? So, dito, sa graph natin, okay, so, kung triangle yung graph natin, ang kasunod niya is parabolic na, no? So, starting from rest din yung velocity natin. Okay? So, starting from rest, and then, a certain time, meron tayo ng velocity, no? Paano yung figure natin? Paano yung parabolic natin? Is it paganto or paganto? 1 or 2? Paano ba na-identify yan? So, dapat yung magiging sagot natin is kung ano yung value ng acceleration natin. Yung acceleration natin is a positive value. So, dapat pag naggawa tayo ng curve, dapat yung curve natin magpo-produce ng positive slope at that point, no? So, ano ba ang positive slope? Refresher natin, positive slope is ganito ang itsura. Slope natin is greater than 0. Pag ang line natin is pag ganyan, less than 0, so negative siya. And then kapag 0, m is equals to 0. Okay? So, tingnan ninyo yung sa graph 1 natin, to, okay? Kapag andito yung point natin, and then nag-pass through tayo ng tangent line sa kanya, ano itsura ng tangent line natin? Parehas nito. Okay? So, ibig sabihin yung slope natin is positive. Eh, yung value natin dito is a positive value. So, ibig sabihin, dapat yung figure natin is yung curve 1 natin. Yan natin yung curve 2 natin. Yung curve 2 natin pag ganyan. No? Eh, di ba kung parabola yan, mag-extend yan pag ganito. Okay? So, ito yung curve natin. Ito yung point natin. Pass through tayo ng tangent line. Yung tangent line natin pag ganyan. So, negative siya. So, ito hindi naman to negative. So, hindi siya pwede. So, ang magiging answer natin, ang curve natin is yung increasing, no? Yan. Pag ganyan yung curve natin, yung parabolic curve natin. Ito yung velocity natin at 6. And then, magiging final natin is, kung ito ay rectangle, kasunod natin is triangle, no? Yan. Okay? So, yan. So, pinapanap is, ano yung constant acceleration natin? Yung value ni A6, no? Si A6 at A50 na equal. Okay? Pinapahanap yan. Again, para makuha yung value nitong graph na to, kailangan area nitong nasa taas, no? Parang katulad ng shear and moment diagram natin by graphical solution, no? Ito yung shear natin, ito yung moment natin. Paano makukuha yung values nito? Kukunin mo natin yung area nito nasa taas. Okay? So, ibig sabihin, solution natin, bawa si V6, no? Para makuha natin siya, kailangan natin yung area nung nasa taas niya. So, area is 1/2 times yung value ng A6 times yung time natin doon. Just 6 seconds, no? So, si V6 meron siyang value na 3 times yung value ng A6 natin. Okay? So, equation 1 muna natin yan. Next, C48 o yung V50 natin, no? Ito equals sa V15. Okay? So, V15 natin equals yan sa ano? So, si V15 is equals yan kay V6 plus yung value natin, yung area ng taas ng graph niya. That is yung A6 natin times, ano ba itong distance na to? 15 minus 6. So, ito ay 6 seconds, ito ay 9. Okay? So, this will be, rectangle lang yan. So, A6 times 9. So, pwedeng A6 or pwedeng A15 kasi constant naman yan. Equal lang yung value nun, no? So, substitute natin yung value ni V6. That will be 3A6 plus 9A6. So, B50 natin given as 48, no? So, this will be 12A6. So, makakalculate natin sa A6 as equals to 4 meter per second squared. So, ibig sabihin, si A6 equal yan kay A15 So, ibig sabihin, ito yung constant acceleration natin for letter A. Okay? Next, letter B. What is the value of velocity after 6 seconds? So, ito yun. No? So, 3a6. So, times natin ng 4 meter per second squared. So, this will be, so ito may unit na S to. So, this will be 12 meter per second. So, this will be our velocity. Letter B. Okay? And then for letter C, which of the following gives the distance traveled in 15 seconds? Okay? So, distance yung kailangan natin. So, kailangan pa ba natin i-graph si distance? Hindi na kailangan, no? Kailangan lang natin is yung area values nito. Okay? So, S15 is equals to yung area ng first curve natin. So, that is parabolic. So, 1/3 ng V6 times yung 6 seconds natin plus trapezoid na. Ito, no? Trapezoid. That is 1/2 ng V6 plus V15 times 9 seconds. So, this will be 1/3. V6 natin is 12 times 6 plus 1/2, 6 plus 48. 12 pala to, sorry. 12 plus 48 times 9. Value of S15 is equals to ilan? 294 meters. Okay? So that will be our answer. 294. Okay? So paano i-check yan? So checking tayo. Dito ko na lang lagay, no? So checking. Kapag graphical yung checking. Kunin natin yung area moment nung acceleration. So yung centroid nito is nandito. So yung distance niya papunta dito sa 15 second natin is ito will be 1/3 ng 6. So 2 plus 9, so 11 yan. And then ito, distance niya is 4.5. So area moment nung acceleration, so S15 is equals to 1/2 yung area ng first curve. So A6 natin is 4 times 6, and then yung distance niya is 11 plus yung area ng kasunod, that is a rectangle. So 4 times 9, and then yung distance, centroid distance niya 4.5. So S15, pag kinalculate natin, 0.5 times 4 times 6 times 11 plus 4 times 9 plus 4 times 4.5. That is also 294 meters. So, check, no? The same as the answer dun sa isa. Okay? Okay? Next, I think this is the final example. So, a train upon passing point A at a speed of 72 kilometers per hour accelerates at 0.75 meter per second squared for 1 minute along a straight path, then decelerates 1.0 meter per second squared. How far in kilometers from point A will it be 2 minutes after passing point A? Okay? So, meron tayong train. So, sabihin natin, ito yung point A na tinatawag natin kay train, no? And then, para after 2 minutes, ito yung point na ano niya, no? Na cover niya. So, yan yung kino-consider natin. So, lagay natin yung ating curve. Okay? So, ito si acceleration, velocity, and then distance. Okay? So, sorry. Acceleration, velocity, distance. Okay? Given sa problem, 2 minutes yung time natin. So, sa gitna na lang, no? Ano tayong 60 seconds and then 120 seconds for 1 minute. Okay? Sabi doon sa una, nung dito si train, no? Ito si train. Nung pagpa-pass through na siya kay A, meron siyang velocity na 72 kilometers per hour, no? So yung velocity at A is equals to 72 kilometers per hour. Convert natin to meter per second. So 1 kilometer, 1,000 meter. Then 1 hour is 3,600 seconds. Okay. Upon calculating, we have VA is equals to 20 meter per second. Okay. So, sabihin nyo na agad yung velocity natin. So, velocity natin, di siya nag-start from 0. Meron na agad tayong 20 dito. Okay. And then sa acceleration natin is 0.75 meter per second for 1 minute along a straight path. No? So, ibig sabihin, mula dito, sabihin natin ito yung 0.75. Okay. Ayan, consistent siya. And then, nag-decelerate siya nung pagpunta niya ng after 1 minute ng 1 meter per second. Yan. So, ito yung 1.0. 1.0. Okay, negative, no? Kasi deceleration na yan. Okay, so move lang natin ng konti yung sa okay. Next, ano pa? How far in kilometers from point A will it be 2 meters after passing point A? So, si point B, yung distance kay point B na natin. And since meron naman tayong acceleration graph, makukuha natin si velocity graph, no? So, si V6 siya si V120. Si V at 60 seconds, makukuha natin, and si V at 120. So, si V at 60 seconds, area lang siya nung acceleration graph natin. So, that will be 0.75 times 60 seconds. So, that will be, so, meron tayong initial na 20, no? Kailangan isama natin yung 20 kasi hindi naman siya starting from rest. Okay? So, 20 plus yung graph natin. So, 20 plus 0.75 times 60, we will have 65 meters per second. Okay? And then velocity natin at 120, that will be yung 65 na nakuha natin minus plus minus nung 1.0 times 60 seconds. Okay? So that will be 5 meters per second. So ano yung itsura niya doon sa graph natin? So dito magiging siyang 65, and dito magiging siyang 5. Okay? So since rectangle yan, triangle yung kasunod. Ayan. Okay? So pinapahanap ngayon is si S120, no? Si SB. Okay? So meron tayong velocity graph. So kunin lang natin. So since trapezoid yung parehas, 1/2 nung 20 plus 65 times 60 plus 1/2 nung 65 plus 5 times 60. So S120 natin to be equals to 0.5 times 20 plus 65 times 60 plus 0.5, 65 plus 5 times 60. That will be 4,650 meters or 4.65 kilometers. Okay? Dahil kasi in kilometers ang hinahanap natin. So SB is equal to 4.65 kilometers. So this will be our answer, no? Yung hinahanap natin. Okay? So, may question ba tayo? So yung kapag i-check ulit natin, I think we can use ulit yung ating kanina, no? Pero kayo na lang mag-check kung same lang yung makukuha niyong answer. Okay? Pero kung halimbawa gusto natin i-graph yung distance diagram natin, paano natin i-graph, no? So since trapezoidal na tayo dito, o yung triangle na to, gawin natin para third degree curve na tayo, parabolic na tayo, no? So, kung halimbawa at distance A lang tayo, so starting from 0, okay? So, starting tayo from 0, baguhin natin yung kulay. So, starting from 0, and then kailangan natin is positive yung maging value nung slope natin, no? So, kapag ganito yung slope natin, yung point natin, ito is magiging 0 siya, no? Pag ito, ayan, ito yung point natin. Yung tangent line natin is increasing, so dapat pag ganyan yung itsura niya. Okay? Then para sa 5, since positive pa din siya, kailangan ba maggumanto na siya? Sige, sulat muna natin yung una. Okay? Una, kailangan maging ganyan. Okay? Then yung sa 5, pag ginawa natin pag ganito yung curve niya, ito is pa-downward siya, pero positive naman to. So, hindi pwede. Dapat pag ganun pa din siya, no? Para yung tangent line natin is pataas pa din. Okay? So, ito will be, okay? So, that will be our graph para dun sa ating diagram, no? So, ito yung para sa velocity diagram natin, and this will be for our acceleration diagram. Okay? So, this ends our lecture for today about rectilinear translation. So for our next lecture, I will discuss yung curvilinear translation natin and yung rotation translation natin. Okay? So see you guys again on the next lesson.